Hello, hi everyone. My name is Babili Sarath Kumar and I am working as a security software engineer. And basically, we are working on a programming language. Rust means we are trying to build secure building blocks. So today's my topic is one of the standard library feature which is present in Rust, which is channels. So today I'm going to explain you how the channels we create in Rust and how to use them and what are the features of a channel and the function of a channel. I'm going to explain you. Let's see through the documentation and where the channel will be present here, and the function prototype of the channel is like it is a public and the function name is channel and it will take a type T, which is a generic type, and there will be a structure sender and there will be a structure receiver. So the structure will have, again it will take a type T, which is a generic type, and similarly receiver will take a type T, which is a generic type. So here are the some of the theory part where what is a channel and how the channel will help in communication, all this stuff. So to creates a new asynchronous channel, return the sender and receiver also. Means when you're trying to create a channel, for example, here if you see, we're trying to create a channel here. So here we are creating a channel. So we are getting two hops. One is transmitter and another is receiver. So these two, when we are creating a channel, we are getting a transmitter and a receiver. Similarly, then after, so whenever the data sent on the sender will become available on the receiver in the same order as it is sent. So this thing we're going to see like how the order is maintained in channels. So whether the sender is sending order, that thing we can see programmatically, and we'll see that sender will not block the code, where the receiver will block the code until all the senders finishes their. If all senders are closed, until then the receiver will be blocking state. Receiver will block until a message is available while there is at least one sender alive. Receiver will block until a message is available while there is at least one sender alive. Okay, we'll see like receiver how it's blocking, and also we'll see the sender how it is non-blocking. Okay, so here and also we'll see the cloning of the sender will be possible, but the cloning of the receiver is not supported. That thing also we'll see. So let's see first thing. Uh, let's begin with the receiver. Cloning of the receiver, we'll see like receiver and sender cloning, we'll see first. Before that, I'm going to explain this code here. So here we have sender. So sender is a structure, you can see like pub structure it is, and receiver is also a pub structure uh, of which is has a type generic type T. Okay, and I'm importing all this thread module and these all modules, and also timer module to show the order of the messages. So we imported the timer module. So here receiver is as we disable the receiver code, that's why it's showing not used. So let's do this. Okay, so this method here you can see no method clone found for structure receiver. So as you seen, there is no clone method is defined for receiver. So that's why when you do the clone, it won't work. And what the theory also says that the receiver cannot be cloned, whereas sender can be cloned. And before going to that, we'll see that. And Now we'll see cloning of the receiver. So here we're cloning the receiver. If you see here, if you see here, we are able to clone. Like if you want to see this like that, and also I can show that the method is not defined for CLO. There is no clone method, so it won't work, and it will give. So if you run that, even if it is if you run this, even the external is showing error. Let's see like what will happen. So you can see method not found in the receiver structure. No method is defined. So that's why we are getting error here. So whereas if similarly if you see for send transmitter, so this is the transmitter. So if you see clone, there is a clone method defined here. So there is no problem. So therefore transmitter can be cloned, whereas the receiver cannot be cloned, as I mentioned in the theory part. So that thing we have able to show that. And next thing we're going to see is blocking. Whether the receiver is blocking or not, we'll see. So I'll show that. Means like transmitter means this code. As you're cloning, there is no not saved. So it giving error. You can see there is no problem when we cloning a transmitter, but when we cloning RX, there is a problem. Okay. So next we'll see blocking, like whether receiver blocking or not. So I'm trying to do like comment it out. So I'm trying to uncomment. Like initially I'm receiver. I'm waiting. I created receiver and using that receiver to receive the data. So how it blocks, we'll see. So we'll print one line below this. Okay, or we can put here receiver waiting. Okay, now we'll see like whether it's so this thing also not printing. So if we put this also, it's the RX receive function has blocked the code. Okay, and now we'll see that same thing in case of sender. Like here, there is no receiver we defined directly. We are creating the senders. So even the receiver is not available, the senders are able to send the data, sending the data, but there is no receiver. So the data is lost, like stored on the shared memory between the sender and receiver. So for example, if I run this, so I'm going to save this and now Control C, same example again I'm running. So now you can see there is no blocking of the code as we don't have a receiver and only transmitters are there which are cloned. We are creating three transmitters of one transmitter of clone of it. We are creating three. So there is no blocking. So the blocking thing we are able to see first we see in the um, cloning of transmitter and receiver, and also we see the blocking. And now we are going to see the order of a transmission, whether it is coming in a proper way or not. We'll see that. So this is the code to receive the whatever the data is sent on the sender will receive and stored here. So we're going to see that, and here we are going to print the data. Sorry. Okay, let's see the order how it's going to work. Now we'll run this. See 0 2 1. See means like which one finished first? You can see 0 is finished first. So 0 finished first means it received 0. And thread 2 finished second. So that's why we received 2. And thread 1 finished last. So that's why we received a, like if you see here, these things based on that 0 finished first. So we received 0. 2 finished second. Then we received 2. And 1 finished last. So we received 1. So same thing if you run again, we'll see what we're going to see. Again, now for first thread 1 finished first, so we received 1. Thread 2 received finished 2. Second we received 2, and thread 0 received 0. Finished third, so we received 0. So whichever thread finishes first, the data will be sent to the receiver. Means if whichever thread sends the data first will be received by the receiver first. Means first in, first received. Okay, so again, to make it more systematic, we'll see that. And only the sender can send the data, and these channels are unidirectional. Only one direction the data will flow, that is from sender to the receiver. And there is no way to send the data from the receiver to the sender in this channels. So only the sender can send data to the receiver. So for example here, now we are trying to create a delay so that make this order of data transmission. We see, so we'll see like how it will happen now. Now we control fashion we are doing the sending, like means we are given a delay which will be like a first thread will have more delay, last thread will have less delay. Like we are creating here three threads. So first this formula will define in a such a way that first first thread will have more delay in this part, here here in this part more delay, and last thread have less delay. So that is the part, like so same thing if suppose that is the case, like code wise, like here what we are doing is like just I will explain the code here what is happening. Here we created a channel and we have created transmitter and receiver, and then we created a vector, and then we're trying to, as we are trying to create three threads, so we're creating three threads here. So for creating three threads, n threads 0 to 1 times we are trying to run this code, which is like used for creating threads and including the sender in the threads. So here like printing that here we're creating clone of it. So here we're getting thread, the print of that. So then we're catching the child, whatever the thread we're creating, that details like join handle we are creating, storing in the child. And the child we are pushing into this as we created the vector here. So into this vector we are pushing the join handle. Okay, all the join handles, we'll get the three join handles, that things we are pushing into the children. So means we'll wait until the all the threads will finished. Okay, so here like again we are creating one more IDs with capacity three threads. So we are creating a vector of three threads is a like receiver. So whatever the data we receive, that thing we are creating here. So for vector 0 to 3 threads, we're trying to push the data whatever we receive. Rx dot receive will receive whatever the senders are sending the data. Means the senders are sent the data first, and the data is stored in a shared memory, and then the receiver is trying to access the data in the same order as the sender sent. As is seen here, like first second data is sent, and then first data, and then 0. So that same order the data has been received here. So And here we are trying to waiting like until all the receivers are complete. Sorry, all the senders. Like here we created a delay, and like anyway it will block. Here the until I like all threads are finished, it will block. We'll see, like we'll remove this, or what we'll do here, we'll create a delay, we'll remove this. We'll see like whether that works or not. So we'll see, check it. Just doing some. So now here what I'll do is I'll put some. Yeah, that's okay. It's not there, so let's. I will do this. Do this. Okay. We'll see. Sender blocked. Finished. Unfinished. Zero finished. So the data is received properly. So means once the data received, then only the from this loop, like every time whatever the data, all the data completes, then only the receiver coming out of it. So now also here what we are checking is whether all the like we'll try to keep a loop like infinite loop. I think it won't work or not. I'm not sure. Infinite loop to create means like we'll check that infinite loop. Sorry. Um, so like if suppose the receiver is not finished, if the sender is not finished, waiting whether the receiver will wait or not. So we have to figure out how many senders are there. So the receiver is blocking, but so every message we received, then it's blocking. So okay, the thing we'll see in the next video. That's it from for this video. Thank you everyone, and I hope everyone understand what is the channel is. If you have any doubts, you can ping us anytime. Thank you.